Welcome back to ChemDoctor, and this is the third video in the playlist on isotopes. And specifically, this video goes out to Tanner D. up at NAU and her colleagues who are in the first semester of General Chem, and anyone else out there who is struggling in their first semester of General Chemistry. And what we're going to do in this video is work a couple of problems that are typical in the realm of the homework. Alright, and so in the first kind of problem, they give you a whole series of artificial isotopes that they've made up, and they ask you to identify the isotopes out of this list that belong all to the same element. So there's basically two pieces of information that we're going to need actually to do both of the problems that are here. The first is to make sure that you understand how to use the periodic table. So I'm going to pull out the box that deals with carbon, and there are two numbers in this box that we need to pay attention to. The first is above the symbol usually is the atomic number. All right, and the atomic number is literally the number of protons. So the number of protons, and the significance of this is that the number of protons identifies the element. All right, so this is key in solving the homework problem that's over here to the left. And then the other thing I want to mention before we move on is the number at the bottom, which is the atomic mass. And the atomic mass is an issue that I covered in the video just before this one. It's a weighted average that takes into consideration the natural abundance of the isotopes that make up this element on Earth or in our universe. Okay, now let's move on to this problem on the left. So they give us a total of 5 different isotopes, and they want to know which of the 5 all belong to the same element. So the way you figure that out is by evaluating the symbol. All right, and what I mean by that is that each of these symbols is in what we call AZE notation. So I'll make up an element called X here, and you notice that in the notations that there are 2 numbers. There's one number that is up and left, and there is one number that is down and left. All right, and the number that is up and left is the mass number. All right, and the mass number is also a very important concept here because it literally is the sum of the number of protons plus the number of electrons plus the number of neutrons plus the number of neutrons. All right. All right. Now, the bottom number is the atomic number. All right, and the significance of this is going back to where we started here. So the atomic number actually identifies which element this is. So when you go back into this list, in order to answer this question, what we want to do is identify which of these 5 things all have the same atomic number. So we can circle this one because it has an atomic number of 7. We can circle this one because it also has the same atomic number, and we can circle this guy here because it also has the same atomic number. All right, these other options have different atomic numbers, so they're not possibilities here. So the answer to this question would be these 3 symbols because they all have the same atomic number, and therefore they all came from the same element. They all are comprised of the same kind of atom. All right, now let's move on to this next problem down below. And this is the classic table where they give you a series of different elements, and you have to fill in the appropriate numbers of subatomic particles. So the first one in the row here is silicon. And you're going to find silicon on the right side of the periodic table. Specifically, it's in group 4A, right underneath carbon. So look, and in order to proceed in this problem, what's going to be handy is to make sure you have a periodic table out. Some of you may want a calculator. if it makes you feel more comfortable. And so getting back to the problem, for silicon, look on the right side of the table, identify group 4A, silicon's right underneath carbon. And when we look at the representation for that, notice that for silicon, the atomic number is 14. All right, and they've given us that number in the table. And as we move across, we can see what they're asking for. They want the mass number. They want the number of protons. So let's go ahead and deal with that. All right, because remember, the number of protons is equal to the atomic number. All right, and we already know the atomic number is 14, so there's 14 protons in silicon. Moving along, it also has 14 electrons, and they've provided us the information that tells us that there's 14 neutrons. So coming back to mass number, remember that your mass number, like I said above, is going to be the number of protons. The number of protons plus the number of neutrons. Plus number of neutrons. All right, now they've given us the mass number for this. It's 14. So the total mass number for this element is going to be 28. 14 times 2. All right, and they ask us to identify the charge. When you look back here at the symbol, you can see that there's an absence in terms of a superscript up and right of any sort of notation for charge, so the charge here is 0. The significance of this is to realize that they've given us the atomic number where there are 14 protons and exactly 14 electrons. So in terms of this particular element, the total number of positive charges equals the total number of negative charges, and the sum of that is equal to 0. So that is the reason why there's no charge on this particular element. All right, moving on to the next option. They give us the sulfur atom that actually has a charge of -2 on it. So this is actually, to name it correctly, this is actually sulfide. So I'll write that number here over to the left. And it has a charge of -2 on it. A negative charge means that this particular element has extra electrons, and the magnitude of the charge tells you how many. So this has 2 extra electrons. I'm going to write that down right here. 2 extra electron. We'll need that bit of information a little bit later. Now moving to the right, first thing they want is the atomic number. So look on your periodic table and you can identify sulfur in group 6A. It's over on the right side of the table and it's right underneath oxygen. It has an atomic number of 16. So I'll put that in. That means it also has 16 protons. When we get to the category on electrons, here's where we need to be careful, because the charge, the superscript in the upper right hand corner here, already indicates that there's 2 extra electrons. And since the atomic number indicates the number of protons, and for the neutral atom the number of electrons, I'm going to actually make that notation here. So for a neutral element, also number of electrons. All right, so normally this element, sulfur, would have also 16 electrons, but since it has 2 extra ones, then the total here is going to be 18. And then they want to know the number of neutrons. Well, come back over here to your mass number and you see that they've given us a mass number of 32, which represents the number of protons plus the number of neutrons. And since the number of protons in this element is 16, then the number of neutrons here has to also be 16. All right, 16 times 2 is 32. All right, moving on to the next element down, notice now that they've given us a positively charged element, copper plus 2. All right, again, the charge is always going to be the superscript that's up and right like an exponent on the element, and the fact that it's positive means that this thing is deficient or is missing 2 electrons. So I'm going to write that down. It's missing 2 electrons. All right, and since it's positively charged, the way we name this is we would call it copper ion. Copper ion. All right, now moving to the right, the first thing they want is the atomic number. So again, go to your periodic table and you'll find copper in period 4 right next to zinc, and it's the element whose atomic number is 29. So let's go ahead and write that in. 29. Alright, and we're going to skip over the mass number for a minute and go to the proton. So remember, atomic number is the defining number because it is the number of protons. So we'll write that in now into this box. And then for the number of electrons, okay, so again, here we need to be careful because in the neutral element there would be the same number of electrons as there are protons, but since we're missing 2 electrons, then for this particular for the representation of the ionized form of this element, there would be 27 electrons. All right, the number would be 2 less than 29. Now, in order to figure out our mass number, we have to pay attention to what the information they've given us here. So there's 34 neutrons in this isotope of copper, and we have an atomic number of 29. So to find the mass number, you're going to sum those two things together. So it'll be 34 plus 29, or 63. So I'm going to go ahead and add that in. And then finally, they've already inserted the charge for us into this last box. So that leaves us now at the last of the unknowns. And how are we going to figure out what element this is? Well, they've given us the atomic number. So again, go to your periodic table and search for the element whose atomic number is 15, because atomic number equal to number of protons identifies the element, and you will find this particular element in group 5A in period 3. It's right underneath nitrogen. So the identity of this element is phosphorus. All right, now move to the number of protons, because atomic number is protons, and we insert 15 for that. It's a neutral element, so they've already told us that there are 15 electrons in this, and then they give us the number of neutrons, which is 16. All right, and so we need to find the mass number. So let's figure that out. It's going to be the number of neutrons, which they tell us is 16, the number of protons, which is 15. So 5 and 6 is 11, carry the 1. So our mass number for this element, mass number, is 31. All right, so let's put that into the box. And then finally, we need to address the issue of the charge. But notice that in this particular, for this particular scenario, we've got 15 protons and 15 electrons. So the charge balance is exactly 0. So let's go ahead and insert that. All right. Now, in future videos, what I'm going to do is go on with the isotope issue. I'll cover mass spectrometry, and we'll go into more detail. All right. And with that, I'm going to sign off.